Well, hello everybody. The bonus quiz for 4.1, a three-parter. Just a heads up, 4.1 and 4.3 throw you back into one dimension. That is a line, the bare x-axis. We're no longer thinking in terms of xy coordinate system in ordered pairs. Suddenly we're dealing just with the real number line. And that will be all the way through until we hit 4.4. And suddenly they're going to shift again, and we're going to go to the xy axis and deal with ordered pairs. Now, this problem could just as easily appear in 4.4, in which case you have to think in terms of two dimensions. I tell you that because I want you to clue in on the language that the problem is written in. In this case, they say solve the linear inequality. And so you're thinking the number line. And that's exactly what we're going to do here. Now, the first problem I created so that we illustrate what's called the addition or subtraction principle. And the second problem will illustrate the multiplication or division principle of solving for linear inequalities. And those are just fancy terms for what comes quite naturally to you at this point in the course. Inequality is like an unbalanced scale. X minus 1 is lesser than or equal to 2, and so it weighs less than 2, and the scale goes this way. Notice if I add 1 pound to this side and simultaneously add 1 pound to this side, the scale is not going to change its slant. However, the left-hand side is now going to look like this, lesser than or equal to 3. So I basically have solved for x. I've simplified this inequality. And this is the solution set for the problem. And so the main deal here going on in 4.1 is the three different ways of writing the solution. Set builder notation, interval notation, and as line graphs. Set builder notation, you just put the answer that you found, the simplified inequality right here. The set of all x such that x is lesser than or equal to 3. Interval notation, well, I'm just going to go ahead and do it. Here is a video right here that explains interval notation in more detail. I'm just going to assume that you're pretty far along in that. It is the lingua franca of calculus. You really want to get strong in interval notation. It's how all the theorems in calculus are written. This says x is lesser than or equal to 3, so x can be 3. That means I want to use the square brackets. That is like a closed circle. It says all the numbers up to 3 and including 3. Notice the arrows running to the left, and that means the solutions are going in this direction, 3 and everything less than 3. And so we're going to use negative infinity because there is no bound. It goes as far as you want to the left. And the question is, do we use an open parentheses in our interval notation, or do we use a square bracket on this side? And the answer is we use this. And the reason is because of tradition, and we have to use one or the other, and it makes sense to use this one because think of this as a stretchable fence, and this is a hard fence. This says up to 3, including 3, and no more. This says we're going to the left as far as we ever want to. And so this is sort of a fence that stretches in that direction. It doesn't include any endpoint here. It just says go as far to the left as you need to. The nice thing about interval notation in our textbook in MathXL is that the line graphs are written using these symbols instead of open and closed circles. So I'm looking for 3 and a square bracket, and the solution is going to the left. And that looks like this one right here. 1, 2, 3, square bracket, everything to the left. Keep in mind the arrowhead tells you what direction the solutions go. So the answer here is going to be B. And let's go ahead and move this aside and move into MathXL. The set of all x such that x is less than or equal to 3, and in interval notation that is going to look like we don't fence in infinity, so and we have to say negative infinity, comma, and the endpoint was 3, and we want to include that, so we go with the square bracket. And so that's interval notation, and we said the answer here was B. And so there's problem 2. Problem 1. Now problem 2 deals with the multiplication principle, and I'm going to actually go to fractions because we need practice in fractions. You can never see it enough. How do you say this number out loud? Negative 6/10. Negative 6/10 times x is greater than negative 24. And so the multiplication principle says that you can multiply both sides by the same thing and not change the inequality. And so you have a fraction that's being multiplied, an unknown that's being multiplied by a fraction, and the idea there is you multiply by the reciprocal, both sides. Now, when you multiply both sides here by 10 over negative 6, you're multiplying by a negative number. And so there's an extra step involved. And here is a warning that appears on page 224 of your textbook. Remember that whenever we multiply or divide both sides of an inequality by a negative number, we must reverse the inequality symbol. If you want to see why that is so, just check out negative 1 less than 1. That's certainly true. Multiply by both sides by the sign changer negative 1, and you get 1 is less than negative 1, and that's obviously false. So that's why we need to reverse the inequality when we multiply or divide by a negative number. So I need to do that. Now, the multiplication by 6 is undone by this division, and the division by 10 is undone by this multiplication. So I have x by itself. Over here, negative 6 goes into negative 24 4 times, and 4 times 10 is 40. So there it is, bare bones solution for x. And how do they want the answer here? The solution is supplementation. The set of all x such that x is less than 40. And in terms of a line graph, notice the arrow is going to the left. So we can immediately exclude these two where the arrow is going to the right. It's either this one or this one. And the question is, do we or do we not include the endpoint? X has to be less than 40, and so this is akin to the open circle. It says everything up to 40 but not including 40. The answer here is D. So let's create some space and move on. And let me get those answers in there. Set of all x such that x is less than 40. And in terms of a line graph, that looks like this one. And so there we go. And the last problem now. Now I did tell you that the domain is going to haunt the course. They're going to constantly be asking you for the domain of a function, and by default when you have just math, you're supposed to assume R, and then you look for any restrictions. We're not dividing by 0 here, so you might think the domain is all real numbers. But let me show you the second commandment of mathematics that says, thou shalt not take even roots of negative numbers. Thou shalt not take even roots of negative numbers. In other words, if we're taking an even root and we have a square root in that problem, so it's even, what's underneath the radical has got to be greater than or equal to 0. So that's the situation here. What's under here has got to be greater than or equal to 0. X minus 7 is what's under there, and it has to be greater than or equal to 0. And lo and behold, an inequality pops out of this problem. And we can add 7 to both sides, and we get this. And so that's the answer. Our domain is not R, it's severely restricted. X has to be greater than or equal to 7. In interval notation, that is going to look like this, stretching out forever to the right. Don't fence in infinity. We want to include 7, and thus the square brackets. And that's how they want our answer. So it's going to be this. It's going to be this. Let's go ahead and do that. It's going to be a square bracket, a 7, comma, and then we just say infinity. We don't have to show a positive sign. I'm not going to tempt fate, MathXL, to handle that. I'm going to put in the right paren, however. We don't fence in infinity. Let's do a submit. And we're good to go on these. Okay, I'll see you on the next bonus quiz.